If you miss class, you should watch the videos because they're class. I did an analysis last semester of students what was a predictor of who's going to get a good grade at the end. The reason I did this is because we want to know this in medical offices, right? If someone comes to the doctor, can I tell early on that they're going to be successful or not? And I thought, well, why can't I do that in my classes? Are there predictors of who's going to get an A? And guess what? Not coming to class was a predictor of not getting a good grade. So it's not a good idea. We covered 91 slides last time we met. 91. It's not like we didn't do anything. We did a lot. So if you weren't here, the good part is you can cover it. So if you had an emergency, you can cover it. But recall that getting used to it is really how you learn things. It's, you get used to seeing it. So you saw those who were here the first time. I can see that. Oh yeah, I remember she said something like that. So that you saw it, just seeing it alone put you at an advantage. A few years ago, I did a study in my class just looking at what was a predictor if someone did well on a quiz or a test. And that class is unusual because all the material was online and they had to download the material to actually study for it. What I saw is, I wondered, is it the person who actually does a lot of work, that spends the most time on it? And I put all the things into equation, and guess what was the predictor? How early they started. Not how long they spent on it. None of that was a predictor, just how early they started. That makes sense with the other guy saying, hey, you just get used to it. Well, they had more time to get used to it. That's what it was. So just keep those things in mind because you can use it to influence your grade. I would love to say it was just, hey, being in my class was enough. It wasn't. I want to show you a couple more because when I went through and David was asking some really nice questions about the hyperbolas and how do you know if it stands up, lays, why is that important? So in this particular problem, number 10, you're given an equation and asked to match it to the graph. And the question in all these problems are the same. Is it a circle? Is it a hyperbola? Is it an ellipse? So that's why that black list is really important because you can just go rip it out of your quiz or test and go, oh, it's one of these. When I looked at this equation, the first thing I noticed is it doesn't look like anything on the black list. Because in the black list, all the x and y stuff are on the left side and the numbers on the right. So I rearranged some stuff here to make it look like something off the black list. Well, to do that, I need to bring the y stuff, which is on the right side, over to the left side. Because that's the way everything looks in my black list. That everything is... My son is learning this stuff in geometry. He's calling it black list and red list. So if you bring that over, can you look at your black list, which you just wrote now on the in-class assignment, and tell me what that is?
Ellipse.
Ellipse. Stands up or lies down?
It stands up.
Right, because the A is under the x squared, and the B is under the y squared, and the B is bigger than the A, right? So you can just look at the list and say which one it is. So I can already tell you that the key mark that is right on A, it's an ellipse that stands up. But I'll give you a few more details so you can see why. Find the A and the B. If I asked you to graph it instead of actually pick a graph, what would you do? Well, find the A and the B. Those two numbers down on the bottom are the A and the B, except not quite, right? It's A squared and B squared. So the A is square root of 12 and the B is square root of 36. I already know B is greater than A, what's your name? Corinne just said that, right? She just looked down at her list and went, oh, it's one of those that stand up. So I already know it looks like that. It's not lying down. And by the way, if you can't tell, that's an ellipse. So then I take those numbers. The A is around 3.5. I just punch it on my calculator. The B is going to be 6. So I just go over to this picture, which I already know is the right answer because I have the green key on it. And I notice that the height here, the A, is 6. And over here, it's about a little bit higher than 3. So it's this one. The B tells you how far to go on the x-axis. The A tells you how far to go on the y-axis. They call that the major axis. The major axis has length 6. The long axis, the short axis, has length 3.5. So it's that one. And I call this thing the center. It's not quite the center because you don't really have a center of an egg. That's why I put it in quotes. It's not really the center, but you all get me, right? That it's they have a nice name for these things like foci and everything. I don't want to call them these names, right? Just forget about all that. You know what I mean by the center? Okay, then let's leave it at that. The midpoint of the long axes. Did you just call me four eyes? Foci? Probably not. I just don't think it's that important, right? Recognition. Can you tell if it's an egg that lies down, stands up? Can you tell it's a circle? That's what you need to know. All right, so that's why it's this one. This is the answer.
How did you get 3.5 and 6?
Well, if you back up on the previous step, because I went over it really fast, what was under the x is the a squared. What was under the y is the b squared. Right, so then a squared is 12, b squared is 36. So a is square root of 12 and b is square root of 36. So a is, when you take the square root of 12 in your calculator, it's around 3.6. Right. Right. So you won't, if you do this process, you're not going to get this part wrong, because when you have to plot it, if the a was bigger than the b, you go further out on the x-axis, and it'll be a line down this a. Right when you do the plot. Well, the way for your black list, the a being bigger than the b is lying down. The a being right. You already know that. I already know that. Yeah.
Okay, good. I go horizontally bottom.
So you said, okay, when the A is bigger than the B, it's going, it's lying down.
Right.
And then when it's the B, it's going to be this.
Right. But you can also tell because when you graph, the distance you go out from the center to the right has to be whatever you got for A. So if the A was smaller, then this distance is smaller than this distance. So you can't even accidentally get it wrong. Does that clear it up? This thing?